This. Hello, hello. Go live, go live. Hello, hello, hello. Welcome, welcome, welcome. What we're doing is we're going to be talking about this thing. What is this thing? This so much. Run for life. Thank you so much. What's 10,000 with the blue one? Okay, wait, I'm sorry. My product is great for students. It depends on if there's adults teaching them. So it really does depend on the people around them. And if you believe in it and you want to teach the students or your children around them, then that's great. None of the students are going to be able to see me unless the parents or the people or the teachers are interested, right? It all comes down. This is how I was taught math when I was a child. Hey, cabbage. What's the 10? Oh, sorry, 10,000, right? This is the 10,000. So if I put the blue one down, that'd be 50,000. It helps many kids with fast math and problem solving. Yes, thank you, user. I've never learned how to use an abacus before. Oh, okay, cool. Hey, hi, thank you, Run for Life, Run for Live, Run for Life, Run for Live. Yes, thank you. Plus, I struggled with the two-digit numbers in my head before the abacus, even if it was on paper. Yeah, see, that's the thing, right? Like, we do a lot of things on paper. Now we're going to be philosophizing, but if you notice, we do a lot of things on paper, right? And if we do the things on paper, like there's this one where, okay, we do this, right? We have 283 plus, okay, so let's break it out, right? What we're going to do is we're going to do 200, right? And then we have 880, and then we have 3, right? We now have things on a piece of paper, but on the abacus, we have 283. Right? We break it up. Hey, welcome back. Welcome back. Because I was taught with an abacus, I visualized math in this out. Yes, exactly. Exactly, right? Because that I was taught with an abacus, I can visualize math in my head. So here I have the number 283. How easy is it to see it on the abacus than it is to write it on a paper? Because don't forget, writing the numbers is still very abstract. Writing numbers is a symbol. So you don't understand, you're not physically understanding what it's doing, right? As opposed to a physical abacus that tells you 283. Now, if I want to add 561, 116, what am I going to do? In new math, they break it up. 500 and then 16, 10, and then a 6, right? So we can do this in new math. That's fine. That's great. But you know what? It's better if you did it on the abacus, because the question is can I add the 5? Yes, I can add the 5. Can I add the 10? Yes, I can add the 10. Can I add the 6? Yes, I can add the 6. So what's my final answer? My final answer is 799. Now, what do we do here? Well, I want to go to Harvard. Okay, great. I think I'm starting to get it. Okay, good. So what's going to happen is, yeah. So what's going to happen is in new math, this is what we're teaching in new math. What happen? We have all these extra zeros. It's too much for I feel like it's too much for my brain. I'm a simpleton. This is too difficult for me. Okay. So yes, Ryan, as a pre-K teacher, 3-year-olds picks up math so quickly with these. Yes. Yes. Thank you. Thank you, Cabbage. I appreciate that. Okay. So the first thing we're going to do is understand the first thing we did understand is if we had enough. We don't have enough. Because we don't have enough, when do we have a question we don't have enough? When the question is 4 plus 4. Now, I don't know about you guys, but I remember when I was a kid, I was taught to memorize. We had to memorize our doubles, right? Anybody remember how to memorize your doubles? Do you remember? Do you memorize your doubles? Yeah, we were taught. I don't know if you guys were taught, but I know I was taught to memorize doubles. Thank you, Neon Panther. So what we're doing in the abacus world is we don't memorize doubles, right? Now in the mainstream, we're teaching the kids how to make a 5. Well, that's all we're doing is we're teaching how to make a 5. Did we touch math? Yes, we are touching math. Thank you, dude, bro, 907. So what we're doing is we're understanding that this is where we're teaching the kids how to make a 5, but that's as far as it goes. What does that mean? Well, what it means is what we're going to do is we're going to take it one more step. So in abacus, we're going to take it one more step, which means we're going to modify this. Where is it? And I don't know what Morrison's math is. I'm a simpleton, dude, bro. I don't know what that means. That's way too much for me. So what's going to happen? Oh, we got to do the 4. So what we're going to do is we're going to add a 4. Why are we going to add the 4? Because we're going to add the 4 because we need to understand that this is the concept we're teaching the kids. Now notice that we're going to try to isolate the variable. Isolating the variable means what? To make the 4 by itself. Thank you, Eve. So what's going to happen is, can you do doubles because there's only one spot for it? You can do doubles because there's only one spot for it, right? Huh. No. No, we don't want to do doubles. We don't want to do doubles because it's not versatile. We don't want to memorize doubles. What we want to do is we want to memorize the formula. We want to memorize how to add a 4. This is where understanding the adding comes into play, right? So the question is I want to have the 4. Can we do it? No, we can't add another 4. So what does that mean? I have this concept. We're teaching the kids how to make a 5. So let's take it a step forward. Let's take it a notch forward, right? One notch forward means what? 5 minus 1, right? Because if 4, and then we're going to substitute this information. When we substitute it, we're going to add the 5 and we're going to take away the 1. And my final answer is 8. What? That's too complicated. No, it's not. Because what happens after doubles? Well, we want to do 3 plus 4. 3 plus 4 is what? People tell you to memorize doubles plus 1. Okay, fine. But, right? Lalo? Yes, it is late for math. I don't know why there's so many people here learning math, but this is crazy. This breaks rote teaches concept for strong learners. Yes, exactly. Thank you, Cabbage. So here, if you notice 3 plus 4, 3 plus 4, 3 plus 4 is what? We don't want to memorize doubles plus 1 or doubles minus 1. What we do memorize is how to make a 4. When we make a 4, we have 3. We add the 3. And then we want to add the 4. When we add the 4, what are we going to do? We are going to plus the 5 and minus the 1. Midnight math. Yes, Eve. Midnight math. Hello, hello. Hey, Shane, thank you. Does that make sense, Sydney? So now we're making the 4 versatile. Understanding how to add a 4 becomes more versatile. It becomes easier to see, right? Oh, the touch points one? That's very interesting. Thank you, dude, bro. But I don't know how that relates to abacus. I don't know how that would relate to abacus. Yeah. So let's take it one more step, Sydney. Let's take it one more step. Let's add the 2. Can we add the 2? On the abacus, it's nice that there's a constraint. Why? Because there's a constraint, now we can critically think, how do we add more, right? How do we do regrouping? We can do that in a little bit, but the first thing we need to do is understand how to make a 5. Is that all right, APO? We're going to go into that. We'll go into the grouping and regrouping, but the first thing we need to do is understand how to make a 5. Clutter pop. Here we go. Let's do a little review. Let's do a review. We do 1. Can you put the paper and the labels behind the abacus? Like this? Or are you talking about like this? I only have so much room. So, yeah. Okay, cool. APO. Yeah, we'll do the regrouping, but for right now we're kind of doing a review. So we can talk about 1, 2, 3, 4, and then 5. The top B will always be 5. Now we have 5, we have 6, 7, 8, 9. After 9, we have 10. 10 looks like that. A 0 and a 1. 0, 1. Because we have 10, now we have 11, 12, 13. So the first thing we're going to do is understand how to read the abacus. Because we learn how to read the abacus, then we can start going into adding and subtracting. Oh, is it proper? 10s and 100. Tenths is over here and hundredths. Tens is over here. So when we look, we have our decimal sitting between the 1s and the tenths. Oh my goodness. Are you a professional teacher? I don't know what that means. Hello, Trouble. Hello, Zeal. Just checking in for a moment to show my support. Thank you so much for your support. I don't get oat. It. Okay. Okay, good, Clutterplop. Are you a teacher for your job? I would like to be. So, Claudia, this is 1. Does that make sense? We have 2. We have 3. After 3, we have 4. Hello, Shane. Thank you, Shane. We have 4. After 4, thank you, Taylor. After 4, we have 5. This is not making any sense to me. I'm about to get one of these because I'm catching on. Oh, good. Oh, good. Oh, good. So, I forgot. Claudia, any rows or is it just on a row? Whoa, oh. So what happens is this is my ones indicator. My ones indicator tells you where I put my 1, right? Just like how we have place values. So if I did my place value here, my 1's over here, then I can do 1. I can do 2, I can do 3, I can do 4. After 4, I can do 5. The top beat will always be 5. After 5, we have 6. 5 plus 1 is 6. 5 plus 2 is 7. Does that make sense, Claudia? Escobar. 704. So when we put it, 7, you have 700, 4 as part of your username, right? This is your username, 704. I learned Chisenbach and I taught my kids. I've always wanted to learn. I don't know what Chisenbach is. How do you do 10? 10 looks like this. Oh, sorry. 10 looks like that. So just as we write the number 10, if I can find my piece of paper. Let me find my piece of paper. Just as we write the number 10, a 1 and a 0, then I have, oh, I see. I didn't know that. So we do 10, it's a 0 and a 1. So this is 10. That's what 10 looks like. 10, and then this is 11. Right? Just as we write 11. And then 12. We have 12. It's Korean. Oh, interesting. Hand abacus. That's very interesting. Yeah, I've seen it. I don't know too much about it. So when we look at it, hello, hey, Tonio, welcome back. Welcome back. So when we look at it, we're just reviewing. So 220 is this. 2 and a 0. 2 is that. And it just depends on the place value of the columns. So every column is different, right? Good. Good, Davy. Good, Davy. How do you add now? What about the 2 green ones? 2 green ones, this one and this one, that's 11. 1 and 1. What you gonna do? Right? 1 and 1. If I did this, this is 2 and 2. If I do this, this is 3, 3. This is 33. 44. And then 55. Works like a Sorbonne thumb is on the... Oh, yeah, I've seen that. Jay says 2 plus 2. So the question is I want to add 2. I have the 2. Can I add another 2? Yes, we can. So we add another 2. So, yeah, it's the labels are nice to have, but I can't always have it there because it'd be difficult to have anything else out there. Like I can't really show you the rest of the number. All right. So we're back to here. Sydney, how are you doing? Does that make sense? So what we can do is we can make the 4 very versatile. So when working with the whole numbers, ignore the last 2. Yes, you could, because why? Because these are decimals. So unless you want it, that sounds always me. Yeah, I like it. I like my sounds. Thank you. You could ignore it, but then, I mean, if you're working with whole numbers, yeah, you can ignore it. Okay, good. You're still here. But does that make sense? What we're doing was we're adding the 4. And we could do the same thing. What do you mean? Well, we still have these ones to work with. So we could do the same thing with the 3. When we add the 3, it's the same thing. Why are we going to add the 3? When we don't have enough, we don't have enough, let's say this one, 4. When we add the 4, right, and we want to add the 3, is there enough to add the 3? No, there isn't. So what do? We have this concept. I want to add the 3. To add the 3, I have to take away the 5 and minus the 2. Add the 5 minus the 2. So my final answer is 7, right? Thank you, Neon Panther. Sorbonne teaches place value intrinsically, something the standard teaching techniques have a hard time. Yes, the interesting thing about that too is the Sorbonne teaches subtraction, which is also very difficult for mainstream math, which is really interesting. Really interesting. Like, I was surprised on how difficult it was for some of the kids to understand what subtraction was. And so in the abacus world, we know that when we take it away, we're minusing 2. So if we have 7 and we minus the 2, all we're doing is we're moving it away from the horizontal bar. So here's the other question. Sydney, I hope you're still here. Sydney, so if I have 3, no, I'm going to have 4. I have 4. 1, 2, 3, 4. I have 4 pennies. I'm not sure where you're at, but these are pennies. These are worth $1, 1 cent. That's not it. That's worth 1 cent, right? So this is worth 1 cent. If I have 4 and I'm okay, I have 4 pennies. I have 4 beads on my abacus. 1, 2, 3, 4. I have 4 cents. 1, 2, 3, 4. When I want to add the 3, I only have a nickel. A nickel is 5 cents. This nickel is 5 cents is all I have. So what I'm going to do is I'm going to trade it in. I'm going to give you my nickel. I'm going to give you my 5 cents. But I gave you too much. Now you need to do is you need to give me back 2. So I'm going to take back 2. And what we do is my final answer is 7. Why the abacus and if we have fingers? Did you ever do multiplication? I don't know. No, I haven't done multiplication yet. I'm still on adding and subtracting. So, yes, thank you for the roses. Jerry, why abacus and pennies if we have fingers? I don't know. This confuses me. Well, because you're in the middle of a conversation. So, Sydney, did that make sense? Thank you, Katie, for the rose. We don't have enough fingers. Okay, I see. It's better when the calculator. This is better than the counter oscillates fast, so fast. Yes. You know why? Because your brain is fast, right? And so it's interesting. It's interesting to see. So, okay. So let's do a little review. Jerry, I don't know if Jerry is interested in learning how to use the abacus. But what we're trying to do, how do you know where to start your life? How do you know where to start your lives? Do you always start from reading the abacus? Yes. Yes. I start always from starting from reading the abacus, and then I go into adding, subtracting, and then depending on how many people comment, we go back to review. So that's what we're going to do is we're going to review because Jerry and Kira came in and they're not understanding. So I would go back and I would review. And we do 1, 2, 3, 4. These are the 4 beats. We will multiply depending on how far we can move the class. Hello, Ashard. So it says 4, and then all the top bead is a value of 5. So we have 5, 6, 7, 8, 9. Jerry and Kira, how does that work? So after 9, we have 10. Because we have 10, we have 1 and a 0. We have 11, 12, 13, 14. Does that make sense? If not, I'm going to move forward to adding and subtracting. Kira and Jerry. So does that make sense, Eve? Yeah. So it all depends on the class. So, I mean, in the middle of the night, there's not a lot of people, then we can go all the way to division. We can start from the very beginning and we can jump forward to multiplication, division. But a lot of people get confused with the pennies and the abacus and so forth. So, ski. This would make my brain explode. Okay. No, it shouldn't make your brain explode. It should give you more wrinkles in your brain. That's what it should do. Learning the abacus should give you more wrinkles in your brain. You don't want to have a smooth brain. You want to have wrinkles in your brain. So the idea is to make wrinkles in your brain. So what I'm trying to do is I'm trying to help you make more wrinkles in your brain. So when we have 4, and I don't know if, oh, hey, Claudia, I believe they don't understand yet because each of the columns. Oh, yeah, exactly. So when you're right, you're right. We have ones. So if we have our ones, our tens, our hundreds, our thousands, our 10,000s. You're right. And so when we are looking at it, we have 1, 2, 3, 4. The heaven bar has a value of, yes, thank you, Shane. The top bead is the value of 5, and the lower beads all have a value of 1. But when we're counting, we can count 4. After 4 is 5. After 5, we have 6, 7, 8, 9, and then this will be 10, just as how we write the number 10. If Jerry and Kira are gone, I'm going to continue adding and subtracting because those are the only ones that seem to be. Okay, so we're done. Oh, how do you know How do you use the fifth line of the beads to explain instead of the first line? There is a dot indicator. This dot indicator is my ones indicator. Because I have a ones indicator, it's like a label. I miss you're so chill. Oh, thank you. So Becky, does that make sense? So what I'm doing is I'm using this indicator. This is my label. Because I'm doing a label, right? Because I'm doing a label, I have my labels right here. So what I would do is I have my ones here. You could start here, but then I'd move everything over and I have my ones, my tens, and my hundreds over here. Does that make sense, Becky? So it all depends on where you want. But then I want to have a bigger number. So if I have a bigger number, I would start here. So then I can move everything over. It'd be my ones, my tens, my hundreds, my thousands, my 10,000. Whew. So clay. Oh, I get it. Okay, good, 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 good. You said you sell these. Yes. You can see it. It's pinned down right there. Yeah. I'm just learning how to use the TikTok shop. Okay. So, clay. We're going to review again. We're going to review 1, 2, 3, 4. Because of the value, these all have a value of 1. Value of 1. This is 5. The top bead will always be 5. Perfect sense. You should also move further to the right to get the millions. You know, if I wanted to make millions, then I would use a bigger abacus. I'm gonna fail TikTok math. I don't know why you would fail TikTok math. Makes perfect sense. Yeah. So what I would do, oh my gosh, I understand immediately. It's kind of binary. It's not binary, it's a decimal. This is just decimal. It's just a decimal system. That's all it is. It's not a binary. It's not a 5 base. It's a 10 base because that's what decimals are. This is just a bunch of numbers. So this is 1, 2, 3, 4, and then 5, 6, 7, 8, 9, and then 10. So when we're looking at it, right? Let's review it. We have 0. That's what 0 looks like. Next we have 1. 1 looks like this. You sell the big one too. I do. It's not the huge one, but I do sell a bigger one. So 2 looks like this. That's what 2 looks like. Make sure that all the beads are touching the horizontal bar. And then we have 3. This is 3. After 3 is 4. This is 4. So after 4, what is 5? 5, that's 0. 5 is the top bead. So then we have 6. 6 is a 5 and a 6. 5, 6. Then we have 7. 5, 6. We need to add one more to make 7. So we have 5 and 7. And then we do 8. 5, 6, 7, 8. Notice I'm moving the beads, right? So this is 9. This is not 9. This is still 8. 5, 6, 7, 8. We want to do 9. To make 9, we do that. Does that make sense, Clay? Sunny says good. Titan just joined. So then after 9, what's after 9? We have 10. Thank you, thank you, thank you. Cam, which is the best, the color one or the non-color one? Teaching math with a Sorbonne, a Japanese abacus. It depends on who's it for, Cam. If it's for young kids, I would use the smaller ones because the numbers are smaller. If it's for you, I would suggest you use the bigger one because you can do multiplication and division. And unless you like the colors, I know a lot of people actually have the colorful one, and you can use a fair amount. You can use like big numbers like 10,000, but if you're going to do multiplication division, depending on how big your questions get, maybe the 13 one is would be suitable for you. That really clicks when you explain. Thank you, Vave. Hey, CompuBear. I find the color easier. Yeah, you know, colors are easier because it's on a screen. But there are people that are colorblind, and so that's not an excuse. So you could use the gray one or the single colored one. I'm afraid just seeing the longer one. Oh, don't be afraid. It's just bigger numbers, right? It's nice to have bigger numbers. You know why? Because more money, right? More money means more bigger numbers. Can you show how to multiply and divide? I can if everybody's ready for it. It just seems like everybody's still stuck on the whole confusion. I'm dyslexic and the colors are easier. Oh, yeah. I'm not sure. Hey, Jake, welcome back. I'm ready. You're ready? Okay, good. Okay, Sydney, we're ready. Do it. Are we sure? See, Sunshine says she's lost. Sunshine says lost. Oh, right, regrouping. Thank you. We're going to do regrouping. Do you think this can help kids with autism to learn math? Yes, I do. I've had a few students that are on the spectrum, and they enjoyed it a lot, and it made a lot of sense to them. I'm not a professional teacher that teaches specifically to autistic children. However, I have had students that come through my school, and they were fine. It's textile. Oh yeah. So APO, thank you for the regrouping. What we're going to do is we're going to do regrouping. The first thing we're going to do is understand we know how to make a 5. What's the next thing we're going to do? The next thing we're going to do is we're going to make a 10. Why are we making a 10? Well, just like in regular math, we teach the kids how to make a 10. Right? How do we make a 10? We make a 10 by doing this. We know these are pairs. These pairs are very specific. 7 and 3 is equal to 10. 4 and 6 is equal to 10. 9 and 1 is equal to 10. These are very specific pairs that we need to make sure we understand. We need to memorize these pairs, just like we need to memorize these pairs. Does that make sense? Now, these are a lot of memorizations. Well, yeah, right. Kids learn the Soroban from a young age and are able to use Sorobans in their head. Yes, exactly, Shane. Thank you. So, the next thing we're going to do is, so we're done with the adding of the 5. What we're going to do is we're going to make a 10. To make a 10, right, to make the 10, we're going to go here. Now, again, here's my question. We'll do 8. So we have 8. We have 8. Okay. 8 is a nice number. Why? Because we're not going to memorize our doubles. We're not going to memorize, no more memorizing doubles. What we're going to do is we're going to memorize our concept. This is the concept. Look, it's very familiar, right? 8 plus 2 is equal to 10. That looks very familiar with the plus 10s or the plus 5s. What we're going to do is now we're going to isolate the 8. We're going to isolate the 8 just like we did with the plus 5s. So when we isolate the 8, we're going to do plus the 10 minus the 2. Plus the 10 minus the 2. That's what we're going to do. Why are we going to do it? Why? Because we needed to cool, right? So we had to modify it. And what does that mean? The reason why we needed to do it is because when we have an 8 and we want to add another 8, we don't have enough beats to add the 8. Thank you, Jorge, for the rose. So what's going to happen is we're going to add another 8. To add another 8, we're going to modify our formula. We're going to modify this number sentence. We're going to make it better. We're going to make our numbers work for us. So when we do it, we want to plus the 10. That's what this means. Plus the 10 means 0, 1. 0, 1. We're going to plus the 10. And here it says take away the 2. We take away the 2. So my final answer is 16. That is what we did for regrouping. You can do this for everything and all the things. So what we just did is we did regrouping, carrying on, trading, grouping, and this is also we can do for borrowing as well. So my final answer is 16. Does that make sense? Let's do some more. So again, what we're doing in Abacus World is we're not going to memorize our doubles. What we're going to do is we're going to memorize and understand how to make an 8. How do we make the 8 work for us? So here in mainstream math, we would say doubles plus 1. Well, doubles plus 1 is not very specific. If you really think about it, doubles plus 1 is not specific. However, adding the 8 is very specific. And so when we add the 7, we want to add the 7 to the abacus. Can I add the 8? No, we can't. So what do we need to do? We need to add the 10 minus the 2. So we're going to plus the 10 and we take away the 2. So my final answer is 15. Does that make sense? So what we're trying to do is understand to utilize a concept, not necessarily memorizing doubles. That's not even a thing. That can't be a thing. And then and making sure that we understand that we're using we're using a nice set of pairs. What did they say? They said friendly numbers. I don't know. They talk about friendly numbers a lot, and I'm like, I don't know what that means. We don't do friendly numbers. Oh, yeah? But that's it. That is the secret. The secret is if you know how to add a 10 and and add a 5, you know how to add and subtract all over the place. I'm sold on it. I'm going to buy this for me and my kids. Wayne, you're welcome. I appreciate that. And I hope to have all of the books ready for you. It'll be fantastic. But yeah, I'm still in the process of building out my curriculum. But I do have a lot of worksheets and I have a lot of worksheets that are very specific abacus based. But the reason why is because the questions are very specific. So what does that mean? Well, let's take a look. Here is my addition table. We have addition table, and usually when we're giving the addition table, we're just giving the whole table. But in abacus world, it's very specific. If you notice, this is the this is blue or green or whatever. I wish I knew this when I was a kid. Yeah, when my kids were little. Oh yeah, yeah. We can live vicariously through other kids. Okay, so here, this green or blue, whatever it's called, right? This is where we talk about, do we have enough? Yes, we have enough. So we have 1, we add the 3. There's my 3. Does that make sense? So that's what this is. Now you see the pink over here? The pink over here is how we add the 5. Now we're going into, but these are very specific numbers. These are very specific pattern. You will start seeing the patterns. And as you see it, you'll see that there's a scale. It will be able to scale, right? So we have the 3. Remember, when we add the 3, we don't have enough to add the 3. We need to utilize our formula. To utilize our formula, we need to plus the 5. What are we doing? We're adding 4. We're adding 4. Let's add the 4. We're adding the 4. I need to find my little thingy thing. Oh, here it is. We were adding the 4. We know to add the 4, what we need to do is we need to plus the 5 minus the 1. We need to plus the 5 minus the 1. Ah, thank you. Thank you, Sydney, for coming by. I'll see you in my next live. Thank you for joining. Okay. Yeah, waiting. Yes, because your kids are young. And usually when the kids are young, it's nice to be able to introduce the abacus. And that was the whole point. The whole point was trying to find parents with young kids. So, but then I found old people that are interested, which is great too. So that's why I was going to go into creating a workbook for adults. So as an introduction to abacus for adults. There's this yellow. This yellow is what we were just doing. It is about utilizing the 10. This is what we call regrouping. So when we were regrouping, let's take a look at this. Let's do 3, and then plus the 8. Notice I don't have enough. But we don't have enough to add the 8. We don't have enough to add the 8. So what are we going to do? We know we can do this. We're going to carry the 1. So we have to carry the 1, which is here, plus the 10, and then minus the 2. So my final answer is 11. How am I supposed to eat them Skittles? Oh, that's funny. Okay. Yes. Yes. Does that make sense? So what we're doing is we're making the 8 more versatile, right? We could do it again with the 4. We could do it again with the 4. What does that mean? Well, notice on my abacus, I don't have enough beads to add the 4. So I'm going to add my 4. I want to add the 8. Because I don't have enough to add the 8, what do? I can plus the 10 minus the 2. So I'm going to plus the 10 and take away the 2. So my final answer is 12. Queen of everything. Welcome, welcome. Do I have to do math before I get the Skittles? Yes. How are we doing? Does that make sense? So let's do this one. We can do 9. When we do 9, again, we're being very versatile. We have 8. When we add the 8, what are we going to do? We're going to plus the 10 minus the 2. And now we have 17. See, this is the reason why we had to learn how to read the abacus, right? Because we learned how to read the abacus. But notice what I'm doing is I'm just moving the beads. I'm not, this thing is not doing the calculations for me. It's showing me the numbers. So when I look at it, I know I have 9 and I want to add the 8. I don't have enough beads to add the 8. I have a conversation with my numbers. I have a conversation with my name, with my math. So when I have a conversation, can I do it? No, I can't. So how do I do it? I have to plus the 10 minus the 2. So that's the difference. And I think that's the difference between mainstream math. Mainstream math, we're not guided to have a conversation with our questions, right? We don't have a conversation and say, oh, what do we need to do? How do we critically think? We're just told, just do it, just do it, just do it, right? But where in abacus world, it's nice to be able to understand critically what we're trying to do. Does that make sense? I don't know what's going on, right? Are we okay? So that's about regrouping. APO, are you still here? We can do more. We can do the subtraction part. How do you teach the kids to know to minus 2 from 10 to make an 8? You know what? Because the kids, we just tell them to do this. We tell the kids 8, we give them the little rhyme. 8 plus the 8 is equal to plus the 10 minus the 2. That is how we do it. Isn't that called memorization? It is called memorization. However, it's also a concept as well. So it would be awesome if they replaced the calculator app on the phones with an abacus. Yeah. I'm going to teach myself and my grandkids. I could not find these when I had them kids. Yeah, they were hard to find. They're now become a little bit more versatile because now there's like more people that know it. So Claudia, memorizing without understanding. So this, they will start to understand that when we add the 10, it's this and we take away the 2, right? We can see the numbers being moved. So that's more of a concept. So knowing how to move it is another thing. Memorizing 4 plus 4 doesn't help, if that makes sense. I'm trying to figure out a lesson to apply to what it says. Oh yeah, I see. Oh yeah, okay. So I'm trying to figure out how to make a lesson to apply to one of my students. Okay, here's a question. How old are your students? I'm hoping to get to multiplication. Hold on, we're almost there. Oh, so Claudia, how old are your students? It would help me to understand how old the students are, because we talk differently to different people, right? So like I talk about this is an algebraic term, right? And what I'll do is I'll relate algebra plus the 2 is equal to plus the 10. So here is what I would do. 3rd grade. So the first thing I would do with the 3rd graders is I would tell them to read the abacus, right? And then what I would do is I wouldn't tell them this. I would not tell them. I would tell them, how do you make a 10? And then what we're going to do is we're going to modify it and we're going to do this. And then this is something that they would have to know. They would know it, and then it becomes part of them. So it's actually not that difficult to tell them to make this, if that makes sense, because they're going to be able to see that when you add the 9 and I want to add the 8, you just plus the 10 minus the 2. So that's a concept. Is it memorizing? It's like riding a bike, right? Is that memorizing? I mean that's really technical, right? When we write our letters, isn't that memorizing? A, B, C, D. Isn't that memorizing? It's kind of the same, right? So knowing how to write an 8 is different. But when we look at it, like this is 9. Is that memorizing? Why are you up so late? Holy cow, man. I can't believe how late it is. I don't know. It just kind of happens. It all depends on the conversation that we have. So, Claudia, does that make sense? I mean, we all have to memorize some parts, but it depends on how we're memorizing, right? If we're memorizing our doubles, that doesn't make sense. But we're memorizing a formula. We're memorizing a concept, right? It makes more sense. You know what I mean? Like, it depends on what we're trying to do. So, like, we have to memorize numbers. We have to memorize what 1, 2, 3, 4 is. We have to memorize what A, B, C, D is, right? So, you know what I mean? Like, it's a little bit of a loaded question. But what I'm trying to say is we don't need to memorize their doubles, because that doesn't make sense. We need to be more specific. So when we do it, right, we need to understand this concept, how to add an 8, how to plus an 8. and they will see how to add an 8. When I have 9 and I want to add an 8, how do I add it? So when I add it, I do plus the 10 minus the 2. It's a concept that they're going to know. Is it a difficult concept? From what I've seen, it's not been that difficult for them to understand. So the first thing we're going to do is we're going to do a little review. Let's do a review because Louis just came in. So what we're going to do is we're going to read the abacus. To read the abacus, it's about how to count. So all we're doing is we're counting 1, 2, 3, 4, and then 5. The top beat will always be 5. Because we have 5, we have 6, 7, 8, 9, and then we have 10. 10, 11, 12, 13, 14. Does that make sense, Louis? So, show them the labels. Labels, labels, labels. There we go, labels. Thank you. Thank you, Claudia. Yep. These are the columns. These are the columns when we talk about it. So what we're going to do is these are the ones, the tens, the hundreds, the thousands, the 10,000. Oh, I see. Yeah, not a problem. Not a problem. So we're going to do 1, 2, 3, 4, and then 5. After 5, we have 6, 7, 8, 9, and then we have 10. 10, 11, 12. We can count by tens, 22, 22, 23, no, 32, 42, and then 52. The top beat will always be 5 no matter what. Say again. Columns. I don't know what I'm saying again. I get it. Okay, good, John. Very good. Right? So what we're doing is we're understanding how to read the abacus. Because we understand how to read the abacus, then we can do some adding and subtracting. Oh, count again. Count again. 1, 2, 3, 4, and then 5. After 5, we have 6, 5, 6, 7, 5, 6, 7, 8. 5, 6, 7, 8, and then 9. 5, 6, 7, 8, 9. And then we have 10. 10, 1 and a 0. 11, right? 1 and 1. We have 21. We can do 21. 2 and a 1. We can do 31. 31 and then 41. Make sense? So when what's after this? This is 50. The top beat will always be 50. We have 5, 5, 5, 5, 5. All these are 5s. Now be careful to not flick too hard. Like, what is it? Like Zeus in Thor. She's counting the ones place and the tens place. Yes, thank you, Claudia. So don't flick too hard. What we're doing is we're just going to be gentle. We're going to be gentle and we're going to be happy with our math. If you're happy with your math, you will know it. Okay. 1, 2, 3. So notice when we do it, right? I'm touching the edge of the bead. So we're not going to be aggressive when we talk about our beads. We're not going to be mad when we move our beads. We're going to just move our beads gently and slowly. I feel like that. I'm sorry. I feel like this isn't that hard to understand. Plus, you're teaching good. Oh, thank you. Thank you, Cam. But so does that make sense? So we're not going to be angry when we talk about our beads. We're not going to be like doing super, you could do it super fast, but you're going to notice that the beads are very easy to move. And if you're not gentle with it, then you're going to mess up your answer. I don't know what W teach is. My abacus is 1 row and then 5. Is it 1 and 5 or is it 2 and 5? That's really interesting. Or is it like this? Is it horizontal? Hello, Krusty Krab. Oh, it means you're a winner of it. Oh, ha, ha, ha. Thank you. It's only one. That's really interesting. Oh, thank you, thank you. I don't know acronyms. I'm that old. Yes, the top beat is 5. The top beat will always be 5. But it's interesting that you have the bottom beat as 5. That's the interesting thing. I've never seen that one before. So, but it still works the same. So we still have 1, 2, 3, 4. You have the 5th one, then you just trade it in, and that would be 5. So then you have 5. The Chinese one is, yes, the Chinese one is a 2 and 5. But not Jason says 2, 1 and 5. So if this is a Chinese one, this is 2. 1, 2, 3, 4, 5, and then you trade it in to be like this. That would be 5. And then 6, 7, 8, 9, 10, and then you trade this in and you do that. When you have this as 10, you have to trade it in again to be like this. So now this does not break my brain because now we're using it as place values, right? This breaks my brain because this is not supposed to be tens. Then we could do 15, and I'm like, oh, that's too much. That's too difficult for me because it's too much for me to think. But there's a lot of trading. Mine's weird. You know what? It could be that they've taken off the top part and they forgot to take the bottom part off. It could be that too. Somebody might have. So it could be that. It could be that yours was modified and nobody really remembered. Can you speak a little bit base 12? Ah, TNG, it's not a base 12. How come the other ones only had one piece on the top? That's because it's a Japanese abacus. But then when I look at it, it's all original. Oh, well, no, but it's if it's bamboo, right? This is made out of bamboo, but it could have been that they've taken it off, right? So I'm not sure. Base 12. You know what I mean? Not Jason. It could be that they removed the top bead. I don't know. I can only assume. I'm not sure. Um, but yeah, I'm not sure why there would be only 1 and 5. I have not seen that. Yeah. Okay. So we are done with this. We are done. Okay. So APO. Everything I find says you're right. Okay. Cool. I don't know. I tried to make it normal, but if you have that one here, I don't know if it's roundy like this, right? If it's roundy like this, you could just use the 4 beads and you could use it like a soroban. But you could still use what you have. It still works exactly the same. So Mike, we're gonna review. Let's review. We're gonna review. We count 1, 2, 3, 4, and then 5. This is the value of 5. We have 6, 7, 8, 9. That's it. That's it. We're done. 9 after 9 is 10. That looks very familiar, right? That's a 1 and a 0. This is 1. This is 1. This is 10. This is 100. And then we have 1,000. We have 10,000. But it's always just a very small, it's about attention to detail, right? So you have to be careful. Don't be too difficult. Don't be angry. Don't be angry when you read the abacus. Don't be mad. Don't be mad. So, are you okay? Does that make sense? So, not just, yeah, I'm not sure about that. I think it's cleaner than the Chinese version. It is cleaner. It makes more sense to me, the Japanese version, than the Chinese version, because in the Chinese version, there's a lot of trading and there's a lot of redundant steps. But there are still benefits to the Chinese one if you've ever used the Chinese one. You could use the middles, right? If you wanted to convert it, you could use the middles if you wanted to, or you can just use the Chinese abacus as what it was. And so it'd be like trading. There's a lot of trading in the Chinese abacus. So if we do 1, 2, 3, 4, 5, and then we trade that in to be this, that's what that would be. So cool. How's it going? We're all right. Does that make sense? Okay. APO. I don't think APO is here anymore. If you're not here, I'm going to go into multiplication. Oh, makes sense. Okay, good. Thanks, Mike. How are we doing? We're going to do multiplication. Yeah, APO. I don't know if APO stuck around for... Multiplication. APO. Aw, APO left. Okay, that's all right. Hi, Axel. Vanessa. I've been waiting all day. Yeah. It all depends. It all depends on everybody. Okay. Vanessa. Sammy says 6 times 8. Nah. We don't do. Hey, E, welcome back. We have to memorize our multiplication table. That's what we got to do. So it's not 6 times 8. We don't do 6 times 8. What we're going to do is 42 times 8. Let me change this out. Quick mess. Wow. Yeah, right? That's crazy. Okay, so let's modify the number. We're going to modify our number. We're going to modify 63 times that by 8, right? I'm all for it. I've never seen one being used. Oh, hey. Oh, okay, cool. So, okay, let's do a reviews for Sammy. Sammy, what we're going to do is we're going to read the abacus. We do 1, 2, 3, 4, and then 5. All the top beat has a value of 5. Because the top beat has a value of 5, we have 6, 7, 8, 9. And then we have 10. So every column is a place value. Does that make sense? So when we have 11, 12, 13, 14, and then we have 15, all the top beat is a value of 5. No matter what, the top beat will always be a value of 5. Because it's a top beat of value of 5, we have 25, 35, 45. This is 55. Cool? Okay. I'm learning math. I dropped out of school. All right. So what are we going to do is multiplication. Multiplication! The first thing we do on the multiplication, understand where are we going to put our numbers. To understand where we put our numbers is we need to count our digits. We're going to count 1, 2, 3. Why are we going to do that? Because we need to know how to put it on the abacus, and it will be easy. I will tell you. I will tell you how to be easy. So what we're going to do is we're going 1, 2, 3. Next thing we're going to do is 6 times 8 is 48. Now, if you notice, we're going to put the 4, we're going to put the 8 over here. Now, the problem is what? That's not the problem. What we're trying to do is we don't need to say 480. We do not need to say 60 times 8 because that's how we do it in new math. New math is what they're doing, right? We don't need to do that, right? What we're going to do is we're just going to put 48. 4, 8. We don't need to worry what place value it is because that's why we counted our beats. Then the next thing we're going to do is we're going to do 8 times 3 is 24. I chose the wrong number. Why? Because there's a lot. I can do 16. We'll do 2. We'll do 2. We can do 2. Or we can do this one. We'll do 24. So we add the 2. When we add the 2, there's not enough beats to add the 2. Oh, yes. Thank you, Brent. New math is lame. 68. Yeah, 480. Yeah, 48. New math is lame. Carrie, yes, Brent. So what we're going to do is notice we don't have enough beats to add the 2. What do? We know to make a 2 is we're going to need plus the 10. So the plus the 10, we go over here. We need to add the 10, take away the 8. Add the 10, take away the 8. Add the 10. We don't have enough beats to add the 10. So what does that mean? Adding the 10 is here. Remember how to plus the 5? So this is now compounding our knowledge of addition and subtraction. So we add the 5 minus the 4 minus the 8, and then we add the 4. So yes, thank you. Our answer is 504. Thank you, Brent. So that's what our final answer is. So what I did was I had to add this 2, and that's what made it a little bit. I'll just do it my way. Yeah, that's fine. Okay, I'm sorry. I'm actually learning something. Maybe you can help. New math necessary. Why is new math necessary when old math just works fine? New math is trying to be more conceptual. Abacus is not new math, just so you know. Okay, so here's a better question. CompuBear. Here's a better question. That was a question that I should be more specific to my questions because I realized that we need to be specific, and there's always a process. So hold please. Here's a better question. Okay, here's a better question. Okay, we'll do a better one. This is a better one. Why? Because that was a lot of formulas, and unless you don't have the formulas, if you don't know the formulas, it's hard to keep up, if that makes sense. So honestly, it's really interesting. This is really interesting. Oh, thank you. Are you paying us? It's 3 a.m. I'm hooked on this lesson. There's always new ways to do math. That's the dope part about math. Okay, so here, let's do this one. 83. And you know what I did notice is new math is very similar to abacus math, which is crazy, and it made me mad. Why? Because in new math, they talk about 8 times 5, right? But they do 80 times 5, which is what we kind of do in abacus math, but we use the abacus to help. 1, 2, 3. We're going to count. 1, 2, 3. So we have 1, 2, 3. We're going to be here. Notice we do 8 times 5 is equal to 40. Because we add 40, we're going to add the 4, we add the 0. Does that make sense, CompuBear? So when we're going to do it, we have 5 times 3. On the abacus, we just add the 5 times 3 is 15. So we add the 1 and then we add the 5. And then my final answer is 415. Right? So what are we trying to do? We're trying to compound our information. Yeah. So how do we do it in regular math? In regular math, we do it this way. 83 times that by 15. Times that by 5. So what do? We do 5 here, carry the 1, and then 4 times 8 times 4 is 40. 8 times 5 is 40, and then you add the 1. So that's what that would be, right? But we do it differently in abacus world. In abacus world, we do it this way. And we do distributive property. So what this means is there's a concept, there's a math term that we do in algebra, and it's called distributive property. Because we do distributive property, it lends itself to more complex math. You got to borrow. I I don't know what to say. I'm rounding up or rounding down. I don't see nothing but M&Ms. Yeah, actually they're not M&Ms, they're Skittles. Get that right. Because M&Ms are big and fat. Oh, you're talking about the other ones. I was thinking about peanut M&Ms. Peanut M&Ms can get a little interesting. Anyways, he's trying to say you got to carry the 1. How do you do it? Yeah. You could do 80 times 5 is so much easier than adding. Peanut M&Ms is not gross. That's not gross. It's just funny how it comes out. Anyways, I don't know what's going on. Mm. Okay, you know what? Let's do another one. We can do another one. Let's do another one. Yeah, I get lost in the conversation sometimes. So what we're going to do again, we're going to understand how to do multiplication. When we do multiplication on the abacus, what we're doing is we're trying to make sure we understand where we're going to put our place value. So we can do another one called 94 times that by 4. So what we're going to do is, I'm sorry, I'm just everybody's. Okay, we're doing another one, and then I think the labels are needed. We can do it with labels, but we don't want it to be a crutch, right? Just finishing my homework. Hold on, see how I can see this. Hi. You go out to the third places. Yes, I do it. I can't see the problem. Oh, sorry. There we go. Thank you. Thank you. Thank you. Thank you. Thank you. Okay. I'm being funny, Jason. Okay, not Jason. Not Jason. Okay. So the first thing we're going to do is we're going to count our digits. We do 1, 2, 3. Because we do 3, are those fruit scented markers? Yes, they are fruit scented markers. That's why I've been using them. You're not lying. I just broke up. Oh, I'm sorry. So 9 times 4. 9 times 4 is equal to 36. So we count 1, 2, 3. We're over here, right? And then what we're going to do, we're going to add 30. 1, 2, 3. We're going to add the 6. 1 and 5, 6. And then what's going to do? Now I'm learning math. Ghosty. Yes, in the middle of the night. We're all learning math in the middle of the night. What are we going to do next? We're going to do 4 times 4 is equal to 16. 4 times 4 is equal to 16. I add my 1, and then I add my 6. And that's it. So my final answer is 376, right? So what are we trying to do? We're doing distributive property. Hey, is it peanut M&Ms, math, or Skittles? That's the question. You're doing your best, sweetie. This is the best. Yeah. So that's the question, right? Like we can do another one. We could do here. We'll do okay, here. Here's another one. 72 times that by 6, right? Oh, thank you, Compy Bear. Rainbow abacus. Yeah, right? I like my rainbow abacus. It's nice on the eyes. Okay, so here we are. We're going to do that, and we're going to do that. So again, what are we going to do? We're going to count our digits. 1, 2, 3. 1, 2, 3. The first thing we're going to do is we're going to do 6 times 7. 6 times 7, oh my gosh, 6 times 7 is 42. So I add my 4, I add my 2. How could we do it if we did not know our multiplication table? You could do cumulative addition. That's what I did with my kids. So let me finish. 2 times 6, 2 times 6 is 12. I add 1, I add 2. So Shane, what I would do is, and that's what I did, was I would have my kids go through and start understanding how to do cumulative addition. But it all boils down to making sure that they understand how to do this, right? So if I did, let's do 4. 4 times 1 is 4, right? That means it's plus the 4. And then we add another 4, which is 8. So that's like plus the 8. And then we did another 4. And so what I would do is I would get them to understand this part. So a lot of be about adding. This is a cumulative addition. And then here, let's say they don't remember they don't remember what 4 times, so 4 times 5 is 20. We know 4 times 5 is 20. No? 1, 2, 3, 4, 5, right? So this is 3, right? We add the 4, I'm sorry, add the 4 is 16. And then we add 20, right? We have that. That's 20. Now let's say they don't remember what 4 times 4 is. Well, they know that they can subtract the 4, right? Then they get 16. So this adds to their number fluency. Does that make sense? So if this is 20, and if I wanted to go back a few, right, then they'll be able to do that. Does that make sense? So what I do is I try to leverage what they know. If I know that 5 times 6 is equal to 30, if I know 5 times 6 is equal to 30, let's say I forget what 6 times 6 is. I know 5 times 6 is 30. If I want to add another 6, then I get 5 times 6, 6 times 6 is 36. Thank you, Ghosty. I appreciate that. Somehow I'm interested. Does that make sense, Shane? So what I would do is I would leverage what they remember. And then from there, they can add and subtract as they go. And that would be part of making their fluency. Perfect sense. Yeah. See, okay, so yeah, so that's what I would do. If 7 times 6 is hard, right? What do you know? You know 6 times 6 is equal to 36. I know if I need to add one more 6, I just add one more 6 and I'll get 42, right? Or even this one, 7 times 8. 7 times 8. I remember 7 times 7 is 49. If I need to add another 7, which is 7 times 8, then I know it'd be 57. Does that make sense? So that's what I would do is I would leverage what they remember. I wouldn't penalize them. I would leverage what they have. 56. Yes, thank you. Okay. Because I'm making mistakes, now I know I'm tired and I need to go to bed. I need to end the live. This is too much. I'm eating popcorn learning. That's funny. Yeah. When I start making mistakes, I know I'm getting tired. So I've been on for a little bit. But what I would do is thank you, Millie Falco and Dylan. I do appreciate it. Thank you. No, I thank you. I appreciate it. I when I start making mistakes like that, it's like, ugh. But does that make sense? So what I would do is I would leverage what they remember, and as they go through, I would remember more. Yeah, I'm ready for bed. Thank you. Of course, of course. No, thank you. I appreciate it. Yeah, yeah. All right. Thank you, guys. Oh, thank you so much for the friendship. I appreciate everybody joining. I do. I am going to end the live. Once I make a mistake, it's like, okay, it's time for me to head out. Thank you for the follow. Thank you for the follow. If anybody's interested, I am selling the abacus. I do sell these on my TikTok shop. I also do sell the other one too, the 13 column one if you're interested. And I'm trying to build out my books. I'm trying to get my books out. Oh, thank you, Shane. Yes, thank you, Shane, for the info. Yeah, not a problem. Let me know if you have any more questions, how to teach and stuff. And that's like, it's just interesting. Like I wouldn't go into specific like this depending on how old the kids are, right? I do this for adults. So, but I do have, I'm starting to build out more study guides for parents and for teachers, so it'd be easier to teach with. But yeah, I'm starting to sell this one too. So this is what I'm calling the abacus formulae, and we're utilizing the 5 bead and the 10 bead. And what it is it's a laminated, and it goes adding the four and adding the four and subtracting the four. And so you can use a dry erase marker to make comments and stuff. So that's what I have. Yeah, I'm trying to build that out too, but we'll see. All right. Thank you guys for joining me. Thank you guys, everybody, for commenting and helping me out, and having a great conversation. This was wonderful. Thank you guys so much. Thank you, Davey, for joining. Right. What is that in the store? This is not yet, but I will be. I just haven't taken the time to add more items to the store. But I'm trying to figure out like how to add more stuff to the store. I feel like I need to do extra math. Yeah, it's not a problem. I mean, if you enjoy, you know what? It's like doing Sudoku but math. Adding and subtracting, multiplication, division. It's an app, by the way. Oh yeah, extra math. Oh, yeah, my kids does extra math, but they're not very specific to the abacus. Okay, that was awesome. Oh, good, great. Thank you, CompuBear. Okay. Yes, I am gonna head out. Thank you guys. Thank you everybody for joining. And yeah, thank you so much for the hearts and the conversation. I do appreciate everybody joining, and I will see you guys all in my next live, and we will do it again. We will do it again. Thank you guys. Have a good night. Bye everybody.